Welcome to Lesson 14, Installation Qualification. In this lesson, we're going to be looking at what is involved in installation qualification, and we're going to be taking a look at two case studies, one for a clean room IQ and one for a mixer process IQ. So we're back looking at the V model. We've explained this already in one of our previous lessons. So the part of the V model we're looking at this time is our installation qualification and part of our implementation phase of the V model. So the IQ tests verification of correct equipment installation. It ensures that correct installation of the system as per the specification has taken place, and it establishes a baseline for equipment. The definition of IQ is a documented verification that all aspects of a facility, a utility, equipment or system that can affect product quality adheres to the approved specifications. So it is of the right construction and is of the right construction materials, and it's properly installed. Documentation must show that what was ordered was correct, what was received was installed properly, and all relevant paperwork was also received and is controlled and filed. Are all the critical components installed correctly? So we're comparing it with our purchase order, we're verifying the environment that it's in, we're powering it up to make sure it works, and then the documents we need to have our operating instructions, we need our logbook in place, and we need our installation support. First thing that we're going to do as part of our verification test is do a P&ID walk down to make sure that everything is where it should be and in the right sequence. We're going to look at the equipment installation, the vessels, heat exchangers, filters, etc. to make sure that they are all correct. We're going to look at the instrumentation installation. Is there temperature sensors, level sensors, flow meters, pH sensors, anything like that? Are they in the right place and are they installed correctly and are they operational? Piping installation, looking at the piping connecting the equipment. Is it in the right order? Is it of the right gauge? Is it of the right materials? The calibration program for our instruments, has that been put in place? Do we know what calibrations are necessary? And the preventative maintenance program, what parts are we going to be needing to change out? With what frequency will we be needing to change them? How regularly do we need to be inspecting each of the components of the piece of equipment? Is there standard operating procedure in place for operating this piece of equipment or this process? And has it been reviewed and approved, and is it controlled? So our first case study then. So take a few minutes to think, how would you approach performing an installation qualification on an IQ? So we talked previously about the DQ, what you would look at, but when we're coming to do our IQ, what would you consider and what approach would you take? If you'd like to pause the presentation while you do it, please do. So our installation for our qualification of a clean room. We would be looking at the IQ is going to be done on an empty room. In an OQ, we would be looking at the typical use of the room, and in a PQ, we'd be looking at the worst case conditions. But for the moment, we're only interested in the empty room and for the IQ. So we're going to be looking at the quality of the room finishes. Obviously, in a GMP clean room, the requirements are very specific about what type of finishes you must have in a GMP room. You couldn't have paint that was going to fleck or cause any flecking into your products. You couldn't have any timber in the room. There's different requirements like that. We're going to be looking at the testing of the HEPA filters to make sure that they're operating. They would be extremely critical in a clean room. Testing of the differential pressures, which again prevents particulates, contaminants from entering into the room as well. Much of a clean room validation will relate to the HVAC, so the supply and the exhaust of the air, and not the actual room itself. Issues to consider for an IQ of a clean room. Well, number one, have the correct mechanical components been installed? So you would be going to verify the make, the number, and the specification of all your mechanical components and checking that they're all tagged correctly. You'll be looking at your fans and your motors, your filters and your housing, and your valves and your dampeners. Then you'll be looking at the control systems. What alarms and monitors are in place? Are they hooked up properly and are they working correctly? We'll be confirming that the materials of construction, for example, your clean room panels, anything like that, are of the correct grade and GMP certified. We'll be looking at the verification of the ductwork again, and we'll be looking at the P&ID. Is all of your instruments tagged correctly and is everything fitted in the right order as it should be? Have the correct services been installed? The power, the water, the steam, gases and chilled water, etc. And are all of our instruments calibrated and up to speed? Have we got our calibration certs in place and filed away? And do we know what our calibration maintenances should be, or our calibration periods and frequencies should be for those instruments going forward? The IQ requirements is it what we ordered and is it as per the design? That's what we're really checking ultimately. So we're looking at the installation conditions, and these apply to the room and to the air handling unit. So the functionality of it, the utilities going to it, the plumbing going to it, and the wiring going to it. We'll be looking at the verification of the layout and the design of the room. So are the P&IDs verified? Is the mechanical and electrical drawings verified? Have we looked at our ductwork, our valves and our dampeners, and are our filters all okay? We'd be looking at the GMP style and the design of the room. So are the room of the proper finishes? Has there been certification received for the panels and the flooring to make sure that they're of GMP standard? And is the plant layout and the drawings been updated to include this new process, equipment or system? Verification then of the utility services. Are they installed correctly? Is the piping okay? Is the electrics okay? Are the pneumatics okay? Steam, purified water, hot cold water and wash water and a thermostat. Any of those if applicable. Are they all installed correctly? So then the maintenance side of things. Have we got our calibration certs? Have we put in place a preventative maintenance schedule? Do we know the frequency of things that are probably going to need checking and inspection and replacement? Have we got those parts available for us? Have the safety features been checked? If there's emergency stop buttons, have they been checked? Does everything work as it should? Do we need to do risk assessments for any of the operation of this piece of new equipment or facility or utility? Have we got a critical spare parts list? Do we know where we can get them from? Have we got approved suppliers for it? And do we know the lead times? Has everything been properly labelled? And is there identification and tagging of your components? So your filters, your valves, your alarms, etc. Is everything identified and has it all been mapped onto the P&ID? So from the supplier, we need to have a P&ID, we need mechanical and electrical drawings, we need our manuals, we need our software documentation and any PLC documents as well, and all of these would need to be filed as part of our validation project. Other certs you might be needing are the PED, the Pressure Equipment Directive, or the ATEX. So for companies manufacturing electrical equipment that are going to be used in hazardous environments, they need to provide an ATEX cert. Verification of calibration status, so your magnehelic gauges and your thermostat as well. Are they working correctly and have they been calibrated and have you got the paperwork to go with it? Okay, so case study number 2. So take a few minutes to think how you would approach the IQ for the following process. So you've got your batch startup where you're verifying that your equipment is cleaned by the operators. The powder is pre-weighed and added to the mixer vessel. You're adding a solvent to the mixer vessel and you're mixing. You're unloading your final solution and transferring into steel drums. Your finished product testing includes conformity to standards, viscosity, assay of drug substance, and uniformity of content. And then your mixer is washed in place. So some more information about it. Your product A and product B are being manufactured in this. The batch sizes are 10 to 250 litres. And then you're adding 5 kg of dry powder and this one up to 97 litres of purified water. Here you've got 5 kg of powder in up to 247 plus or minus 0.1 litres of purified water. Our mixer speeds are 5 plus or minus 2 and 2 plus or minus 1. Our mixing temperature is both 25 plus or minus 2. And our mixing duration goes from 60 for product A up down to 10 for product B. A summary of the key requirements for this vessel are: it has to have the capacity to manufacture all products, it has to be GMP compliant, the powder has to be added manually via a detachable hopper, the solutions have to be added automatically by direct connection to in-house water or solvent supplies, and it has to have an automatic mixer cycle programmed to control duration, temperature, mixer speed. It has to be washed in place. It has to have the capability for wash in place. So this is your P&ID drawing for the vessel. So our IQ requirement: is it what we ordered? Is it as per design? So what we would be looking for, first of all, the GMP style and design. So 316 grade is the normal grade of steel that's used for food grade and GMP surfaces. It has to be easy to clean. It has to be smooth. You can't have any areas where dirt can hide or can't be cleaned. You have to have certification of all of the product contact parts to make sure they're of the proper materials. You have to have a wash and place facility, and you need your plant layout drawings updated. So our installation conditions: you need to check the functionality of the equipment. Is it working properly? Are the utilities attached correctly and are they working? And is the wiring okay? The verification of your utility requirements then. So we've got compressed air, we've got electrics, we've got pneumatics, steam, purified water, hot and cold water, wash water, and the thermostat. So have all of those things been properly installed on the piece of equipment? The maintenance then, we've got our calibration certs, our preventative maintenance schedule. Any safety features have to be checked and make sure that they're working properly. Our spare parts list, our labelling of all pieces of equipment, all valves, all pipework. The ID of the equipment itself, has that got an ID number and has it been added to the PM preventative maintenance schedule for the plant? We would check to make sure that we've got our certification, your PED and your ATEX certifications in place. The supplier documentation then, have we got our P&ID drawings verified? Mechanical and electrical drawings are included and verified, our manuals and our software documentation. And have we verified our calibration status? For our flow meters, they would be critical to make sure we're getting the right amount of solvent or water into the tank. The timer is important. We need to make sure that it's agitating for the correct amount of time, and we need to know the correct speed that it's agitating for also, and our thermostat, so we need to know that our temperature is working to the correct specifications also. So how many of those items were you able to predict? Thank you very much for your time and attention. We'll see you again for the next lesson.